I'm going to have 2x plus 1 equals, because really we need to be able to solve for a, don't we? Let's see, I got a times x minus 2 plus b times x minus 2 plus cx squared. And what was b? B equaled 0, 0, negative 1/2, and c equaled 5/4, didn't it? Let me double check those just to make sure I don't screw anything up. Negative 1/2, 4/4, we're golden. Now the question becomes, how am I going to solve for a? I already used x equals 0, remember? This guy went away. And then I used x equals 2. Crud, this guy went away. Well, what should I use then? Well, I've used 0 and 2. Why don't I just pick another number, kind of arbitrary, that's easy to use, plug it in, and watch what happens. If I let x equal, what's a gentle number? About 1. Doesn't that imply that a times 1 times negative 1 plus, now we already know what b is, so I can write this as negative 1/2 times 1 minus 2 plus, we already know what c is, 5/4, right, times 1 squared. And that equals, well, when x is 1, this guy's 3. And look, I have a simple equation to solve. I'll run you through it. This is what? Negative a. 1 minus 2 is negative 1, so this is going to be plus 1/2 plus 5/4 equals 3. So negative a plus, let's see, 2, what is that, 7/4? And since I'm going to be dealing in fourths, I might as well turn this guy into 12/4. Right? So negative a equals 5/4, so a equals negative 5/4. Which implies that 2x plus 1 divided by x squared times x minus 2 can be written as negative 5/4 over x plus negative 1/2 over x squared plus 5/4 over x minus 2. That is a partial fraction decomposition. We took a fraction and we broke it up into its component partial fractions. That's kind of cool, huh? Now, there's another set of rules that I want to go over. Okay? If I have a quadratic that isn't factorable, so let's say that we had, I don't know, let's go 3x. I'm stuttering. And then let's go over x times x squared plus x plus 1. And notice, this guy isn't factorable, and it's a quadratic. Now the rule is this. The numerator has to be 1 degree less than the denominator. So when I bust this thing up, I'm going to write this as a over x plus, now my denominator is going to be x squared plus x plus 1, which we know doesn't factor, right? However, when I put the numerator on here, it's got to be 1 degree less. So if this is quadratic, this becomes linear. If this were cubic, this would be quadratic. I'll do one more with you. Now this gets really tricky and problematic when we start trying to solve this thing out, which I'll attempt to do with you momentarily. Look close. I know that this sort of flies in the face. Let me show you. Let me back up. Remember how we broke, let me change my color here so we make sure we understand. Remember how we broke this guy up into this guy, right? We had an x and we had an x squared term. Now why was that? Because x squared factors into x times x. So we accounted for the x term and we accounted for the x squared. You may say, well, Ripley, why didn't we just write ax plus b over x squared, right? Because this is a quadratic, which means its numerator could be a linear. Well, in essence, that's kind of what we did. We just made it easier on ourselves to do it this way. It's much simpler to deal with it in this manner. And you'll see why. Again, I may ask you an extra credit question about that. Now, in this case, look, this is not factorable. It doesn't look like a perfect term squared. Okay? It's not factorable, so I have to write a linear term over it. Okay? Now, let's go through this one real quick, and then we're almost done. Thank you for your time and your attention. Oh God, I forgot what we were doing. So 3x minus 1 over x times. So 3x minus 1 over x times x squared plus x plus 1. And what do we say? This is going to be a, notice a over x. This is a constant, which is 1 degree less in a linear term, plus bx plus c over x squared plus 1x plus 1. Right? So right back to what we do. We're going to have a times x squared plus x plus 1 plus x times bx plus c, and that's going to equal 3x minus 1, and the whole thing is over x times x squared plus x plus 1, and we get to get rid of that and ignore it. Now look close. Do you see anything that might work? Well, I see that x sitting all by itself right there. That makes life good, because I can let x equal 0. And let's see what happens. Well, what happens here is I just get a, don't I? Because if I let x equal 0, that's a 0, that's a 0, that's plus 1, so I get a, plus 0 equals, when I stick x equals 0 in for this guy right here, I get negative 1. And look at this wonderful piece of information that I already have. Okay? Now, I'm out of ideas, aren't I? Because this guy didn't factor, there's no number that I can stick in there to make that thing equal 0. So who cares? Let's just let x equal 1 and see what happens. Doesn't that imply that, now I already know that a is negative 1. So I go negative 1 times, when x is 1, let's see, all those are 1s, so I get times 3, plus x is 1 times b plus c, I'm just plugging and chugging, and that equals, let's see, when x is 1, I get 3 minus 1, so I get 2. So I get b plus c equals 5. Oh, crud. Well, I got b in terms of c, or I could have c in terms of b, but I don't have it all by myself. So how am I going to do this? Well, how about letting x equal, I don't want it to, let's let it equal negative 1. Because won't that give me another equation with b and c in it? Because again, I already know what a is. Let's see how this plays out. So a, let's see, what's a? A is negative 1. So if I plug this in, I'm going to have negative 1 times, negative 1 squared is 1, minus 1 is 0, plus 1. Oh, that's nice. That's a pretty number, right? Plus, let's see, x is negative 1 times negative b plus c. And let's see, when x is negative 1, I get negative 4, don't I? So if I distribute this through, I get b minus c equals, okay, now I don't want to do too much of this in my head. There's negatives flying everywhere. Negative 4, right? And then I'm going to add 1 to it. I get negative 3. Now look, 2 equations, 2 unknowns. Add them and watch what happens. C's cancel. Just a simple algebra 1 move. 2b equals 2. B equals 1. If b equals 1, then c equals 4. Isn't that pretty? Nothing to it. So I can rewrite this whole thing. I know that 3x minus 1, and I'm going to want you to do this for me. I'm going to want you to write it out for me. X squared plus x plus 1 is equal to negative 1 over x plus x plus 4 over x squared plus x plus 1. That's the partial fraction decomposition. Now, one last thing, then I'll take you through one quick little deal. We're not going to do the whole thing, but I'm going to take you through one quick little exercise, and then we'll be done. One last thing. Partial fraction, let's actually write this up. Partial, my voice cracked. Fraction, I'm just going to be lazy. Frac decomp is only necessary. And again, you'll realize this in calculus. I know it's going to drive you guys crazy, but you won't have to deal with this in terms of its applications until calculus. Is only necessary and really only doable when the degree of the numerator is less than the degree of the denominator. Otherwise, you long divide. So if you had something like this, let's go 3x to the fourth plus 5x squared minus 9x plus 2, and I wanted to do the partial fraction decomposition with, say, I don't know, x cubed minus 4x squared plus x minus 4, right? If I wanted to do the partial fraction decomposition, well, the degree of the numerator is greater. So it doesn't make sense to do it the way that we're doing it until after we long divide the denominator into the numerator. And we know how to do that. I mean, it's awful. It's a terrible process, and I used a really ugly fraction for it, but we know how to do that. Because then, once we've long divided, then we'll end up with a remainder where the denominator is greater than the numerator. We saw that back in Algebra 2. I'll elaborate on that more, even though you probably won't see it, if you need me to clear that up a little bit. Excuse me. All right, one last one. All I want you to do is set this one up, okay? So I'm going to go, let's go, who cares, 4x squared plus 3x minus 1. And this one's going to be ugly. We're not going to solve for it. I just want you to be able to set it up and see how you do. I'm going to go x times x minus 3 times x plus 4 squared times, and let's go x squared plus 3x plus 1, and then times, let's go x cubed plus 5. Now, again, we're not going to do it. I just want you to be able to set it up. So try it. Hit pause on your viewer and see if you can come up with the partial fractions that you're going to make. All right, there's clearly going to be 1, 2, 3. Ooh, that one's a little tricky. So play with that, and I'll meet you back here in just 1 second, and then we'll be done. See if you can set it up. All right, hopefully you gave it a shot. You ready? I'm going to take that factor. All right, that's easy. A over x. Phew. And we'll take that factor. That's easy. That's b over x minus 3. Ooh, this one's not as easy. Because remember, there's that trick. If it's squared, then I'm going to go c over x plus 4 plus d over x plus 4 squared. If this were cubed, I would have to go x plus 4 squared, x plus 4 cubed, etc., etc. Okay? Plus, you'll see a couple of those, but not too many of them. Plus, now this term right here is quadratic, so what do I got to do? I need to go ex plus f over x squared plus 3x plus 1. Notice it's linear over a quadratic. Now, this one's cubic. So what are we going to do? What do we have to do? X cubed plus 5. I need a quadratic, and this is where it gets a little ugly. EF. So this is going to be gx squared plus hx plus I. Quadratic over a cubic. And then you just go through your spiel. Now, again, I'm not going to give you one this nasty. It's not going to be this ugly, but there will be a couple ugly ones in there that you're going to have to play with. All right. I hope you enjoyed it. We're going to do a bunch of them in class. I'll teach you, we'll talk more. Hopefully you've got some good questions for me. Write those questions down. Why do I do? When do I do? How do I do? Et cetera, et cetera. And then I'll talk to you in class tomorrow. Have a good day.